Hi, I'm Dave Robinson, and welcome to another screencast where I'm going to be analyzing data in R that I've never seen before. So just like every week, I take a dataset from the Tidy Tuesday project from the R for Data Science online learning community, and I'm going to analyze this data. I download this data into R and analyze it. It looks like this week I'm looking at US PhDs awarded. That's exciting for me. I got my PhD in 2015 in quantitative and computational biology, so I'll be excited to see what broader trends I can discover here. All right, I don't want to look at spoilers. Okay. One question I'm wondering is, this is the clean data. All right, let me see. This is. Oh, that's handy. I think they added a line that I can directly read it in. So this is the clean data, but here are. Oh, okay. Let me see. Oh, this is cool. Okay, so there's some clean data here, but there's also some. It looks like messier data in the NSF. I think I understand how this is structured now. So the question is. This is going to be exciting, I think, because this would be, how would I clean data that's not necessarily clean from the start? So I'm going to try that out myself. So I'm going to do download all tables. I'm going to work from that. That means this is going to be a day where I'm doing a bit more data cleaning and less visualization. And I think that's going to be exciting because it's a really important part of the process. The data is not always going to come to you clean. So I'm going to start with this datatables.zip. I'm going to open it, going to, and it's unpacked. Okay, I'm going to work from this file. It looks like every one of them has, the PDF is not going to be very useful, but the Excel is going to be useful. Every one of them has an Excel spreadsheet that we're going to have to parse in and clean. Oh, this is exciting. This is some not the world's cleanest data. I'm excited about it. Are you excited? I'm excited. Okay, I go into RStudio. I create an R Markdown folder, and I'll call it, I believe it's US PhDs. Okay, and I'm going to do tidyverse, read R, read CSV, and I'm going to do, let's see, it'll be downloads, what is it called? It's called, what was the folder called? It was called data tables. And here we go. It's not a CSV, it's a read X. I think it's actually read Excel that I wanted. Read XLSX. Here we go. Okay. The first thing we notice is if I try reading it in, it's going to have a problem that there's a few lines in the way. There's this table 6 or table 1. We have to skip this line, and this line. Probably all three of these lines. I think there is a skip. So I'm starting out by reading one version. I think there's a skip argument. If I said skip equals 1, good, it would skip one line. I probably want to skip 3 to get to the point where it's year, doctor, recipients change from previous year. So I'm already a little bit closer. That's still so much less data than I'm seeing in the other sheet. But I could take a look at a few other ones. I'm going to start with just this one. I can also look at detail the last few rows. This one's not nearly as messy as some of the other files. If I try looking at I'm not sure, 1707. This is that more complicated data. Okay, in this one was a little messy. I had to skip the first 5 rows. Okay. I don't even know what the difference between these are. I'm going to take a look for a second. Oh, wow. Every one of these files is a totally different format. So I'm probably going to by major field of study, by fine field of study, by broad field of study, and sex. So we have analysis of gender, of citizenship status, ethnicity, race, and citizenship status. We have subfield. Oh, so we don't actually want to analyze all. We don't necessarily want to analyze all of them at the same time. I wasn't sure whether I understood that yet. Every one of these is a different format. This is all from the National Science Foundation. This is going to be where I'd start. I'd start with major field of study. All right, so each time we work with one of these, I'm going to be cleaning it. This file was called tab 12. Well, I already have it downloaded, so I'm going to go ahead and use tab 12. So I'm going to look first at major field of study. Okay, and I'm going to do skip. Let's see. Tab 12 looks like what? All right, this number matters. This is not a tidy data set. This is every 5 years, a number and a percentage are coming out. This means we're going to have to do a little bit of tidying. We also have, let's see, this is field of study. Sometimes it's a general field. Sometimes it's a more specific subfield, and that is actually, I think, that's controlled by. What's funny is, what matters is about how many spaces there are at the front, doesn't it? I don't even know how we would get that out of because it's not actually indented, is it? I don't know how I'd get that. That's interesting, because that's gonna make it hard to do these breakdowns. All right, I'm going to I may return to that. For now, I know that I want that. If I'm looking at this data, I want to skip the first 3 columns. They're not that, the first 3 rows. They're not that useful. No, try 2. Where's my years? Oh, I'm on the wrong table. Okay, what we have is year, then the year repeat, but as a percentage. Year, then the year repeat as a percentage. We also have field of study. This gets us closer than we were before. So I'm going to call this the table. So we'll call it major fields raw. Is we read in, I'm going to zoom out a little for this round. Okay, these are major fields raw. We're going to need to do some tidying. And what I need to do is get, here it is, number and percentage are probably both columns, but this is also going to be, these are going to have a problem. Okay, I need the column names to be, all right, I'm going to start by gathering. This takes a tiny bit of thought, because I need to gather these. I need to say gather I'm going to rename field is field of study. I'm going to gather everything except field into key and value. It's really just kind of a tiny bit. It's already really not very clean. And the other thing I need to do is say every x1 needs to get the number 1987. Am I right that if I did distinct key, it'll go 1987, the next one, 1987, the next 2? All right. I'm going to actually say, I'm going to take this key and say if string detect key, if it starts with X, just make it an A. Otherwise, keep the key. That way I've replaced all these with NAs, and I'm using tidyr as fill to fill the values forward. So I'm going to, this is fill data. I want to fill in the missing values. So I'd say I want to fill, I did fills missing values using the previous entry. Okay, well, you know what, actually, I don't actually need to fill any particular columns. I could fill all of them. Why did I do that? I was taking advantage of the order. It's because now I have, oh, no, it didn't happen. Fill key. Yeah, that was what I was trying to do. Okay. And I also need to know the difference between number and percent. So here we go. So I'm going to actually say I need to always have the last of either number or percent. So I'm going to be adding another column before I do my filling. Type is I'm going to replace, this is cute, I'm going to take from my value. If the value is either, see, I told you this data would be messy. If the value is either number or value, I fill it forward. Oh, I make it an A, otherwise value. Here we go. Oh, nope. Oh, I meant it other way around. If it's not number or value. And then after I put it through the fill, now fill key and type. Now I know whether it's a number or a value. Now that I've done that, I can, yeah, this is way more helpful, because I could actually say year here, year and type, and now I've got my year, my key. Well, I don't need the key anymore. I can say as numeric of this, and now I've got a year column. I've got a type column. I need to remove those values, but then I can I need to say value equals more data cleaning. I wonder if I'm missing. Well, I could actually just say as I could actually just say it a little simpler. I could say as numeric of value, and it'll sometimes be NA. Yep, NA is introduced by coercion. And now I can do my spread type value. And what I get, I still have these keys. I didn't want those keys. I wanted those keys to be if else, if there's an XX, I want it to be removed. Oh, I still have a key. I don't want a key anymore. I need to select minus key, and it doesn't like it. Oh, because it doesn't have a I'm not spreading year. I'm spreading. Let me see. Type value. Does data get duplicated? I'm missing something. All right. Here's the data as I currently see it. Where do we see multiple field type? Field type and year. We see 1987 pop up twice. And we saw it before on lines 22 and 68. I can use slice to grab particular values. These look like they're both 142 and 1.4. How'd those two end up with the same data? 1.2, 87. Because one of them should be percent. Oh, wow. Yes, it meant I wrote value there. It should have been percent. The whole purpose of this was to separate our values, and now I should be able, let's find out, to spread type and value. Here we go. There's number and there's percent. Oh, but it still has the silly key. There we go. Okay, so that took a little bit of work, but what I end up with are fields. I end up with and the number and percentage from each. Well, and that's A is a little more data clean. That I think was a footnote in the original data. Okay, so in 15 minutes we were able to get for each of these fields. I can also filter not is an A field. Or I can just filter not as in a value now that I think of it. Oh, it's not called value anymore. And I need to do that up here. Okay, and we can check one value. 2012, for aerospace, etc., should be 307 and a 0.6 increase. Aerospace engineering, 307.6 in the year 2012. Yeah, all right. Looks pretty good. Is this the raw number of people? Maybe, but maybe it's in thousands. It's probably raw number. Sorry, I accidentally zoomed out. Doctorate recipients. Okay, cool. So we have it in each of a few selected years. All right, so that's by major field of study. I also might be interested in fine field of study, and I want to find out how different the data is. This was number 13. So we're going to call this major fields. Notice I've cleaned the data. We have a variable field, tidy the data, I should say. Field, year, number, percent. We could clean it a little more, have these maybe be lowercase. I like them being lowercase. But the key thing is we no longer have data stored in column names as we did in the original form. This makes it very easy for us to say, for example, major fields, filter field is, what's a good field? Where's my field? Mine was biology, and mine would be biological and biomedical sciences, or maybe it would just be life sciences. I'll filter for life sciences. And now we can do visualizations. We can say year, number, and see the number of people getting a PhD from each year. We couldn't have done that with the original data. It was wide instead of being tidy. We could add a couple of fields. We could say field is in any of sample 6 random fields. Field sample unique 6, color equals field. I've got a line plot now. We could have made an interactive visualization. We could have done a lot more with this. What's this look like? Materials science engineering is going up. Health sciences going up by a lot in PhDs. Education administration shows a sharp decline between, I think this is 2007, 2012. Some things we learned from the clean data. Okay. We still haven't distinguished, we still haven't seen the difference between our major fields and our minor fields. I'm going to bring this here so I can analyze it better. See, these, like life science is like a top level field, and these are some categories within it, but we lose that data. Okay, maybe the janitor package could get back out. I don't have, that's janitor packages. I think a package from Jenny Bryan on cleaning and interpreting Excel data. I don't know quite enough about it necessarily I haven't used it recently enough to remember how to pull that data out. So I'm going to stick to, let's take a look at our major fields, at our fine fields. Fine meaning meaning here, it's a fine field of study. So fine fields raw would be, I think, number 13 instead of number 12 in the same folder. All right. Oh, this is much easier. Wow, this is way easier. Oh, I see. This is 383 rows. How much did major fields have? With a count field or a distinct field. 45. Okay, so that's the distinction. All right, so fine fields raw. This is much easier to clean. On this one, I would do a gather. I would do first a rename. What is that first name? It is fine field of study. I think I can do, I need to remind myself of this. I think I can do rename field equals 1. Yes, and it will let me actually rename the first field, whatever it is called. I then want to gather everything besides, I want to gather year, number, and everything besides field. And that will let me do mutate year is as numeric of year, number is as numeric of number. So that's pretty handy. I wonder where I got an NA. Is there an NA in the year? That would not be good news. Nope. Is there an NA in the number? Yes, in 2008. I wonder if we have missing data. I'm going to open it up. 2008. Yeah, we have a bunch of NAs here. Na 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 na. Na 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 na. All right, nothing wrong with that. I'm probably just going to filter it out. I'm going to say, yeah, keep all our data. So this will be called find fields. That was easier to clean than the first one was. And now I can do filter field in sample unique field 6, ggplot year by number. Oops, I forgot color equals field. Okay, and now I can start visualizing by field. Again, once you've got in the tidy form, like this becomes a lot easier. We could do a lot more with this. We could nest it. We could fit models to see which are fastest increasing and decreasing. We might do more of that later in this session, but I'm interested in focusing on our patterns for cleaning data. This one was just a gather and a few mutates to get the data to be numeric. The other one was took a little bit more effort. Okay. I'm going to take a look at one by, let's start by sex. Actually, my first screencast was of I believe, college majors by, it used income and it used, I think that was, it was gender rather than sex. But the, so actually that was a couple months ago, but it's cool I actually get to look at this data perhaps for PhDs now. So I'm going to start with major field. Okay, let's try this one. This is number 15. I could download it, but I'm just going to open it. Doctorate recipients by sex and major field of study. We have, all right, this is going to be pretty clean, except we have a couple of rows at the top. I don't know if they'll mess it up. We have a change column. That I think we're not going to need that because we can compute it if we have to. One thing I just noticed here. All right, one thing I just realized, I didn't even think about this. Do any of these, this could be really important. I noticed there are commas here. Oh, nope, good news. The commas pop up in Excel. They aren't in the actual data. The reason I was nervous is that if we had any commas in this data, if we had any, that would actually stop us from being able to parse them. If I said string detect number, just put a comma, I think I can, that would have been disastrous. I would have used, instead of as numeric, I would have had to use readar's parse number function instead. Okay. Okay, that was just me noticing an issue. Where is... Aha! Okay, the challenge in this one is that it again uses indentation meaningfully. And we don't even have a way of pulling these indentations out. Let's see. Okay. All right, the only two sexes this used are male and female. Yep. Okay. And which includes, all right, so this includes ones who didn't report sex. All right, it's important to note those distinctions. Okay, then what I'm going to do is, let's read it in. I'm using sex because their terminology described it that way. Again, I don't know whether they defined it as sex or gender in this case, and what their guidelines were. But I also say fields by sex. And let's see. I can try reading, I think it's, which file was that? Was that 15? That was 15. I skipped 3. Good. Skipping 3 was what I needed. I do a rename of the first one. I renamed, I'll say major. I'll just say major. I said major. Is that different than field? Major field of study. It is still field. My bad. Okay. So if I said field and field is 1, and I'm going to apply, now that I'm looking at it, a lot of the same code. So far, it looks like it works. The problem is that we lost a variable here, which is sex. We lost the difference between, excuse me. We lost whether it's all doctor recipients, male or female. Looking through this now, male and female. Okay, the way that I would go about this, it's similar to what I was just doing. Before I do the gather, I'm going to remove this so I can do parts of the cleaning. I often do that when I'm working on cleaning. Before I do the gather, I want to say, where is the field in all doctorate recipients? Remember there was an A there. Or male or female. We notice these are 3 rows that they're notable in that they affect all the following rows. All of these are under the male category. All of these are under the female category. Okay. So the by the way, I think it's. I just realized there's like broad, there's major, there's subfield. I don't even know what fine is. I'm just noticing I might want to use that definition. What does this one look like? Okay. Broad is this top level. Major is the next level, which we don't have in this one. Okay, and then subfield must be after that. We're going to come back to that in a minute. I wanted to get a sense of what these broad levels were. But what I'm going to say is I'm going to call this a vector of sex. And I'm going to say filter, mutate. I'm going to say the field is, sex is if field is one of these, then keep it. Otherwise replace with NA. Otherwise use NA. So at this point, I'm doing a similar approach with my fill forward that I was before. And that means I can do fill sex. And now I fill this column forward. I also want to remove that change column. Select minus, I don't even know the whole thing. I just want to remove the column that contains change. Yeah, because like I said, I can compute that other ways. Now we have field, we have sex. Now I can do the gather, but I throw in minus sex into this one. Okay? And, all right, all doctor recipients A. I don't know about you, but that A is going to keep bugging me, so I'm going to throw it into the, I'm going to throw it into my cleaning, is we say, field is, I'd say FCT recode, field, recode all doctorate recipients for wherever there is an A. Recode is useful for replacing one value. And now I need to replace it here. Sex is 3. Oops. I know what I did. I need NA character here. And I need if underscore else. Oh no. Oops. Yeah, recode turned it into a factor, which is actually not great in my following if else step. That was not fantastic. That was a little bit frustrating on my side. Wish I had a version of recode that didn't turn into a factor. I could have just used if else. Oh well, it's not too frustrating. I go ahead and I gather it, and now we have field, sex, year, number. So, I'm going to actually replace all doctor recipients with just all. And now, why am I doing this approach? Well, it's because there are a lot of kinds of, so now I can say fields, sex, and I've tidied the data. Why have I tidied it? Because there were 3 variables. There was field, 4 variables. There was field, there was sex, all male, female. There was year, and remember, all contains people that did not report when given a choice between male and female. That includes year, and includes the number of graduates. So those are our 4 variables. We don't have the as original. We don't have separate rows for the male and the, for a whole set of rows for male, a whole set of rows for female. That's handy because now I could say, let's see, I could filter for, let's remove the all, and let's pick just, leaving this is like, it's like this is the number for everyone. We can leave it for now, but it's not really quite appropriate. It's not quite this field. I'm going to go ahead and say field, not field in sex, so that we keep it clean. We keep this data just these just being fields. Okay. And what I'd say, and now, yeah, here's what I'd say is if I say field is, let's say life sciences. I now have male and female. I could graph this a few ways. I could graph this as a year, number, color equals sex. And see a graph like that. This would show the number of degree recipients that are male or female in life sciences degrees. So generally majority female PhDs, but both are going up a little bit, it looks like. If I was more interested in the total than in the breakdown, I could have said create a column and do a fill. And I get a stacked bar plot. Here it's a little less, here it's, yeah, there's similar trends, but it depends on what I wanted to focus on. But that only works because I've tidied the data in this way. Okay, I could also have said, I'm going to put it back to the line plot. I think it's a tiny bit more informative. I could also have taken this and spread. I could have said spread sex number. Now I have a column for all female and male. If I was interested in the most disproportionately male or disproportionately female PhDs in, say, a particular year, I could have filtered for year is 2017 and mutate percent male is male overall, for example. I could have done arrange in descending. What are the most male and most female areas? It looks like we have fields being aerospace, aeronautical, astronautical engineering, a couple areas within engineering, physics, CS, and the areas that are the least male include teacher education, other education, generally education, psychology, health science. Okay, so we get a this is a breakdown. This would have been interesting in a cleaned data set. All right. I've now realized something interesting. We have 3 levels here, and the 3 levels. You could never have told this from the data. We had to look at the Excel. But the 3 levels are broad field, like life sciences, then what they call their major field, like, I think, for example, let me go back to one of these earlier, less sorted versions. Here, such as biological and biomedical sciences. But there's a 3rd level too. Notice we have subfield of study and sex. So if we looked at number 16, I'm jumping a lot around. I hope I'm not giving anyone vertigo. If we look at number 16, what we see is we have subfield. We have all fields. Life sciences is major. 2nd is this level. But then if you could have had, there I am, bioinformatics. Or maybe I'm computational biology. Mine was called quantitative and computational biology. So it's sort of up to them how they would classify it. Probably because it has the words computational biology, that's what I would use. But yeah, that's how I'd be categorized. Biological and biomedical sciences. This is your subfield. So they didn't express that explicitly, or they probably did somewhere in this documentation. But we did understand based on the fact that we have 3 types of files. Now that I know this, there's actually something kind of interesting I can do. What I can do is, I realize I don't have an immediate guide for what is a major field, what is a minor field, what is a subfield. But I do if I look at the data. So here in number 15, Oh, I'm actually going to use number 14. Heck, I can use one of... Well, I guess we don't use broad field. Oh, yeah, I'll use this one. If I use number 15... Oh, I'm sorry, that's 14 broad field of study. Let's say I read in number 14. So I'm going back up here. I'm like, get the broad, major, and subfield. I'll say actually broad field names and the major field names. I need to get those out if I'm going to have a hope of separating them, because again, I've lost the indentation information. So what I'm going to get is if I read this, looks good, and I'm this. I'm going to include all doctorate recipients A as one of the as an item in here, so that it doesn't so that I can easily remove it from these cases. I just want to get the field names. I have this. I rename field equals 1. I filter for not field in sex. Now, what I've discovered is, I meant to be looking at 14? Yes. There are only 10 major fields. I can pull them. I can say, I need to skip. Do you skip another row? I need to skip one more row. I think. Let me check that. I'll take a look at that in a second. Pull field. All fields. Yes. The 5 genders. All fields A. There it is. Okay, yes. It's so annoying with all these little B's and C's at the end. That actually is going to be, frustrating. I am going to, where do I reorder it? Where do I recode it? I'm going to try recoding it here. Field equals case when field in, nope, not a case when. I meant an FCT reorder, a recode. I'd say take the field when it's make it life sciences when it's life sciences B. I don't hate how it turns into a factor, it's supposed to. And add in other is. I'm going to quickly turn it into a character. All right, so what we learn now is these are our broad fields. That's a useful vector to have. I could have gotten it manually. Couldn't have gotten the next one manually, though. In this next step, I'm going to look at the subfields of study. I remember that was number 15, and then we had to skip one fewer row. Just try to keep it in my head. Take that one. This is not subfields. These are major fields. And drop these. I don't know if I'm going to need them. Here are your... I'm going to need them, but not exactly the same way. I have no idea if this is NEC footnote. I'm just going to leave that. I don't know what to do with it. Along with doing as character, I can do unique. It's not life sciences. Not life sciences B. It's maybe I didn't need it. I don't know why I thought I needed it. Or was it life sciences A? Yeah, it was life sciences A. Nope. If not, I think I got a little bit lost. That's okay. What I get here is major fields. But I actually noticed the major fields, it's 44 fields, more than the 10, but it includes our original subfields. I'm going to add one more step. Set diff with broad fields. That means remove the items that are already in the broad fields. So these are your subfields. Okay. Why have I been getting those vectors? because now when I look at the more detailed fields, which I'm about to look at number 16, which includes fields of study. Which includes it is a subfield. Wow, it's a whole different structure. Oh, it's only 2017. Okay, I'm not going to use the subfield because I wish I had subfield and time. I do not. Okay, so I'm going to just use, let me see. Yeah, I'm just going to use it on number 15. Oh, I didn't even need this section. We'll come back to this in a second. Okay, why have I been going to this effort? It's because here I am. I'm at the step where I'm at this step. We haven't quite gathered yet. And I may as well say not field in sex. Okay. And not field in sex. Let me see. Oh, yes. I want to know for each of these, is it a major field? And I'd say mutate major, broad field is the word I was looking for. If the field is in our broad fields vector, then we include it, otherwise NA. And now we can use our same, now notice that. We have our broad field. We also have the NAs for each of these, and we can use our old friend fill. In fact, we can fill both of them at the same time. Broad field and sex. So this is how oops, I cannot do this filter. In fact, we're going to do it a little later. Object year not found. Missing a pipe. That was an adventure. I'm going to take it one step at a time instead. What we get here is after this mutate, we have our sex, we have our life sciences, and this fill does all the magic. It says fill the now we know all the things that come after this row until the next one that has male or female. All of those are going to be all. Similarly, these are for life sciences, the top level, and then the subfields. So it's broad field, and when I say subfield, I mean major field. Similarly, these four are physical sciences. And now when I gather, I do minus broad field. Minus broad field and field. And I'm going to let myself arrange it slightly differently. Yeah. Oh, the order doesn't matter. All right, so now I have a field and a broad field. And that's useful because notice this, it seemed like that was a lot of work and all I got was this variable. But remember, this variable didn't exist in the original Excel. If we take a look at it, it's like, this is not the right Excel. Here it is. In this one, in this row, there was no information that, chemical engineering is a part of engineering. Teacher education is a part of education. So we've had to add that column to keep the data tidy. And this is the version I'm going to want. I don't need this data anymore. I don't need the major fields vector anymore. I'm going to say this is recipients, year, field, sex. I think that's right. I think. All right. Now if I say broad field equals life sciences, here's what I like about this. Let's say I took this and I said broad field is life sciences. Now I can graph this again, but I can divide it by, facet wrap it by your field. So this, for example, would be a way of comparing the subcategories of life sciences. I could have filtered out the one where it was just all life sciences. This is a total field, which this graph doesn't make clear. I could also have said, what's another broad field? I could also have said, let's look at all the mathematics and computer sciences. And I look at the major fields within those. So it looks like in all three, generally more male recipients than female. And we see, I think, looking at this, male has generally been increasing while the rate of female graduates has been more flat. Yeah. Now, so that's one way of doing these graphs, is fascinating by the major. But it also gives me ability, if I did do an operation where I spread, like I do here, I spread the sex and the number, and remove the filter. Now I have my percent male by each field by year, and I can filter that for one broad field. I could say within engineering, let's plot, let me see, it would be year, PCT male, with color as the field, which is really the major field. I'm just not referring to it. This broad field, the major field. Scale, I like to do scale y continuous labels equals percent format. Okay, what this is showing is most fields within engineering, and that's that we could label these axes a little. We could say year, y is percentage of PhD recipients reporting as male. Remember, it's male overall, not male compared to male plus female. Reporting as male. And this is field. It's a lot of lines I might have. When I actually see a lot of lines like this, here's a handy trick. I think I've done it once or twice before in these screencasts, is I say field is FCT reorder the field by PCT male. What that'll do is, I might need to do it backwards. I need to remind myself. No, yes, I need to do reorder by negative that. Why am I doing that? So that these line up. That we can say, that we see, it's 1 to 1. I don't have to search for the whole thing. So it looks like mechanical engineering is, oops. I meant to put the minus sign there. That made a really confusing graph. Mechanical engineering is one of the areas that is most male, as well as aerospace, aeronautical, and astronautical engineering. One of the ones that's closer to 50-50 is bioengineering and biomedical engineering. All right. So that would be like one example of one graph. And we would have titled that major fields within engineering, engineering being the broad field. Gender, breakdown over, I should say breakdown by sex over time within engineering major fields. And I'd say color is major field. So that will be one graph. This is about time for me to set my theme, set, theme. I like theme light. And so this is one step within engineering. What other majors are there? Count broad field. What are the biggest majors, smallest majors? Don't pay attention that the numbers are duplicated across all across time. Another would be education, that has a few, but not as many as engineering. Or let's look at humanities and arts now that I think of it. Humanities and arts, major fields. Humanities and arts. All right, so here it looks like most of them are not that far from 50-50, and they've all stayed, in some right, they've stayed steady over time. We accidentally left in other B. I'm gonna have to take a look at that. And some of these are definitely going to take a little bit of examination. Yeah, like here's one other, but I think other B is a broad field in this case. Yeah, it should have been other. Yeah, the problem was these there it is. I did not do renaming here. I need to say, I'm not going to use FT reorder because I'm nervous about the, here it is. Oh no, I'm already using FT reorder. I'm going to say field is other B becomes other. Oh, that's the engineering one. Okay, this actually I think makes a lot more sense. Yes, I don't get all the others combined into humanities. That was Happiness Humanities was the last one in that table. So it looks like humanities and arts, that's the whole field in this case. Close 50-50. There's two areas, history and other, that are a little more male. There's two areas, letters and foreign languages literature, that were a bit less male. That's one that we learned. We could do a couple more graphs like this. I'm going to do one more within education. I don't know how much, I don't know how many major fields there are within it. Okay, so education administration is a bit more male. Teacher education, generally less male. The rest of them hovering around 30%. Okay, so we're able to make a couple of graphs out of this tidier data, and all thanks to the fact that we have our broad field categories. So most of what we did today, it was all about learning how we tidy our data to go from a form that looks like this. This is our main one. Look at this. The fact is we have a couple problems. We have years in columns. We have an extra percent change. We had to skip several rows. And most importantly, we have the distinction between sex, a broad field of study, and major field of study is all denoted by indentation. And we needed it to be populated within every one of these columns. So we were able to do that with a couple of steps. Recall we did it with a little bit of cleaning, of renaming and removing. We cleaned up some we cleaned up. Oh, I can find this. We cleaned up some footnotes, and most importantly, we filled in NAs. We created new columns that had NAs that needed to be filled in, both for sex and for broad field, and then we used fill to say, if you don't have a field there, fill it forward. After that, it was a gather, some cleaning, and a little bit of filtering, and boom, now we have our tidied data. So this in the end was the operation we wanted to go through. We did this cleaning, and then we have this one, and then we were able to look at, then we were able to graph the data a little bit clearer. Okay. All right, well, that concludes today's session. I had a really good time cleaning some data in interesting Excel spreadsheets. I'm really excited that they offered that Tidy Tuesday offered a data set where it could show how you'd get from slightly messier data that's in an Excel spreadsheet that hasn't been formatted and made ready for you to use in R, how you'd take that, how you'd think about it, and how you'd get to a place where you could do graphs and visualizations in a clear, sort of tidy way. Okay, so thank you for joining me, and I'll see you next week.